So welcome to the last talk of today. Hopefully this can be fairly interactive. This talk is just a panel discussion about the effects of PQC on SPDM. How many of you are aware of SPDM and what it is? Raise your hands. Okay, good number of you, thanks. You know, that'll make, because we hadn't really planned on going into any background. You know, security and protocol and data model, it's a way of attesting devices inside of a infrastructure. Never thought it'd go outside the box, but apparently some people are using it for that, so it's always exciting to see what somebody does with something you've made. Just quick introductions though. My name is Jeff Hilland. I'm a distinguished technologist at Hewlett-Packard Labs, Hewlett-Packard Enterprise. I'm also president of the DMTF and co-chair of SPDM. Brett?
Yeah, so I'm Brett Henning. I am a security architect at Broadcom, and I'm the other co-chair of SPDM.
I'm Xiaoyu Ruan. I'm a security architect at Intel. I contribute to SPDM.
Hi, I'm Jordan Hand. I'm a senior software engineer at Google, and I contribute a lot to Calyptra, and I lead our PQC efforts in Calyptra firmware.
So we've had a number of talks on PQC. We've had a number of talks on SPDM here. I don't know if any of you have been to any of those. If you have any questions in the middle of our talk or whatever, feel free to come on up and ask questions. We're more than happy to entertain them. I've got a few subjects for us to discuss, but if there's something you'd rather have us talk about, please feel free to just come on up. So we've got a work in progress out as far as the impact of PQC on SPDM, but it's PowerPoint only. You can go out there and download it now, but I wonder if one of you would like to discuss just in a nutshell. Xiaoyu, you want to just kind of what's the general overall impact of the spec itself?
Yeah, so today SPDM latest version is 1.3. It doesn't support the post-quantum algorithms. For example, the two endpoints can negotiate ECDSA or RSA, but for asymmetric algorithms, it cannot negotiate like MLKEM or MLDSA. So as soon as nThe has been working on this PQC algorithm standardization, and they published the standards in August this year, SPDM Working Group has been working on supporting the SPDM, supporting the PQC algorithms, namely MLDSA, MLKEM, and SLHDSA, which is Sphinx Plus, into the negotiated algorithms list. So in SPDM, the two endpoints, request and responder, they will first do negotiate algorithms. The requester would send a list of supported algorithms, and the responder would choose one algorithm from each category, like signature or key exchange. So in the upcoming SPDM 1.4, what we are developing right now, we are going to add the three algorithms I just talked about, MLDSA, MLKEM, and SLHDSA, and all their flavors. For example, MLDSA, MLKEM, they each have 3 different security strengths. And SLHDSA, it has 12 different parameter sets. So the SPDM negotiation algorithms will support all these variants of PQC algorithms and their parameters. So the two endpoints can start to negotiate and agree on the common set of PQC algorithms for this SPDM connection. One thing to note is that we currently do not plan to support the hybrid, meaning the two endpoints can only negotiate one algorithm per category. You cannot negotiate both RSA and MLDSA, for example. You have to choose one of them. That could be our next step, but we haven't considered that so far for the hybrid signature or hybrid key exchange, just to keep things simple for the first adoption of the PQC in SPDM. Because of this addition, and especially because of the key sizes and the signature sizes increase because of the PQC. For example, the MLDSA has like 4,627 bytes of signature, versus ECDSA is 96 bytes, so it's like 50 times more. We have to increase the length of some commands like request and response. For example, the get certificate command, certificate could be as big as hundreds of bytes right now because of the MLDSA's large key sizes and large signature sizes, we cannot just leave with 2 bytes to represent the size of the message, the certificate chain. We have to increase that to maybe 4 bytes. So there are some data structure changes to accommodate the higher lengths of the data structures, including the signature and the signature and certificates, and key exchange protocols as well. One other thing to note is that NIST has not published the MLKEM key management guideline, which is SP 800-227. It's supposed to be published by end of this year. So we're looking at NIST to publish this SP 800-227 to decide in the SPDM key exchange protocol how we're going to adopt the MLKEM in the key exchange to replace the ECDSA today. So we're still pending that SP document from NIST. Otherwise, we are in the process of developing the spec and trying to publish maybe Q1 next year.
Well, whenever it's ready, right?
Right. Yeah.
So, you know, you brought up the hybrid question. I don't know if anybody has an opinion on that that you'd like to share.
Yeah, so for many of you who may have attended the Calyptra OCP community workshop on Monday, I talked a fair bit about this. I think there are lots of uncertainties in doing hybrid right now. So IETF does have a draft spec for a hybrid signature scheme that specifies a bunch of different algorithm combinations, one of them being MLDSA and ECDSA, which we're targeting in Calyptra as the 2 supported algorithms. The main concern I have with implementing that is it's a draft spec and it has several to-dos, several placeholder OIDs, things like that. And for Calyptra and for many other devices that need to initiate DICE in ROM and publish or generate certificates, X509 certificates in ROM, if you implement a draft spec and it changes, then you're not compliant anymore. So I think there's potential value in doing hybrid. I think it makes sense for SPDM to target the individual algorithms first, and then we can potentially build extra schemes on top of that, where devices can implement the individual algorithms in ROM, and then you can exchange those in a CA for a hybrid cert or something once the specs are more mature.
I'm curious how all that works. Brett, you had
Yeah, I was just going to say that those issues that you that you spell out, that you've hit on Calyptra, those are the exact same issues we've been hitting at SPDM, right? It's just, you don't really want to write a spec that references a draft that might, just move out from under you.
right.
Yeah, I think it is good for SPDM to kind of have a stated direction for like what SPDM next, 1.4 is going to support, so that devices have a guideline for what they need to fix in ROM. Obviously, I think it's very uncommon for a device to implement all of SPDM in ROM. I would not recommend doing that. So mainly we're focused with the certificates that are generated in ROM, and then if the SPDM protocol evolves, I think we can accommodate changes to that. So for like certificate formats, certificate, like what algorithms we're going to accept in certificates, I think that's something that's good for SPDM to take a stand on.
Sure. So, Xiaoyu brought up one of the dependencies that we've got, which is 800.227. I've heard that may be delayed and might not happen in time. Brett, I wondered if you'd comment on the dependencies that we have, because it's not just 227. And then, at what point do we just pull the trigger, or do you have a thought on that?
Yeah, it isn't just 227, right? We also depend on the X509 specifications. We did at least clear the bar of getting the NIST standards that specify the algorithms. That was really our first hurdle, was just getting those in place. Trying to think those are the big dependencies I'm thinking of. But yeah, and as a standards body, we're trying to balance the desire to make a complete standard and really just get as much done in one shot as we can. We're trying to balance that with the need to get something out there, because I know the industry has a critical need for post-quantum support, right? People are kind of beating on all of our doors for this. And so, we're definitely trying to balance the two. So basically, I don't think any of us plan to wait forever for every single dependent spec to be in place.
Yeah. Well, one thing I want to add to that is I think a lot of the specs we're depending on are targeting like web PKI, they're coming out of IETF. I think in data center environments, we have a different set of challenges. We have devices where things are implemented in hardware or in fixed firmware that need to live for 10 years. And so like we can't wait too long to do something for PQC. And I think as long as we're comfortable with the cryptanalysis side, I think that's the thing to get right, more so than being compliant with TLS, with what TLS is doing.
Yeah, that was originally, if you saw our previous whip, it was mentioning TLS, MTLS, instead of waiting on 800.227. It was like, now you've got hardware dependent on software, and the hardware lead times are just incredible when compared. You've got to wait for a full turn of silicon, and given the CNSA recommendation of signing firmware next year, and it's October, boy, that's a tricky one. You have a question?
Whoa, there we go. I'm John Gelman, Kioxia. I would really like some feedback on one of the things that I don't understand about hybrid is in a world of store now, decrypt later, how hybrid isn't just leaving keys under the doormat.
Go ahead.
So yeah, in most cases with hybrid schemes, let's say you have ECDSA plus MLDSA, what you end up requiring is you require both to pass. So you're not going to fall back on really either one, but you end up requiring both.
Right. So
And the same is true.
So there's no fallback, then what's the point of having two?
So the main goal is that these lattice schemes, so MLChem, MLDSA, are pretty new. The cryptanalysis on them is a lot less. So if you start using if you just use MLChem now to protect your stuff, that we're not necessarily worried about a quantum adversary right now, and then that turns out to be broken for things unrelated to quantum computers, it's just like the math has issues, then you've just lost any data that you protected with that chem scheme. So keeping the classical algorithms that we have trusted for a long time and have a lot more confidence in allows us to have a more transitionary period where okay, we're not really worried about a quantum adversary right now, but we are worried about getting all the infrastructure in place to support PQC algorithms. So it's kind of like training wheels until we can get to a point where we fully trust the PQC algorithm.
yeah,
But that doesn't address the store now, decrypt later.
well, but so
So if one is going to go bad,
sure.
then it's bad.
Well, but that's not necessarily the issue. Nobody has broken the current RSA algorithms, right? There was a press release out, a bunch of news yesterday about somebody kind of coming close to a 22-bit key, not a 2K key. And so, we're a long way off from somebody developing a post-quantum computer that can actually break the keys. The fear isn't in the RSA algorithms, it's in the uncertainty of the new algorithms. So yeah, if somebody breaks one of the new algorithms and you're just relying on it, you've obviously got a hole. But if you're using the traditional algorithm, well, okay, maybe somebody breaks it someday, but we're more worried about the newer algorithms than we are the ones that have been around forever, because they've been around forever. They've got decades of history in the math behind them. As far as you're just leaving stuff around, people can take traces now with the RSA keys, right? Yeah. And so, that's a real concern. These devices live 10 years, years or more. And if you've encrypted data at rest, you know, you do potentially have that issue, which is why we want to get post-quantum out now. Maybe we double encrypt it, but you're not just single encrypting it, you're double encrypting it.
Yeah, so the goal is, if you break both algorithms, so you break, you know, MLChem now, and then you break ECDH later when you have a quantum computer, then yes, we've lost. But if you break just one of them, then the hybrid scheme protects you from that one broken algorithm.
Okay, thank you.
You bet.
Can you?
Oh.
I can't hear you.
Yes, please come to.
So if you are signing with, say, a traditional thing like ECDSA and then with a post-quantum thing, will there be any expiry? Because certificate, they have expiry date, right? So you can say this is the expiry date, and after that, you update it. So after this, if you feel that now the post-quantum thing is more stable, then you can disable this.
So for certificates that we produce in mutable firmware, I think that's doable. So like for SPDM alias keys, for certificates produced in hardware or in ROM, that's challenging, right? Because if you have hardware that doesn't work past the expiration date that you set, that's a problem.
Suppose in hardware you store certificate in OTP and you have some way to disable, and you need to have enough OTP space in order for you to store a new certificate, right? That kind of thing. I don't know.
Yeah, I mean, if anyone would like to put 16K of fuses in their device, you can do that.
You know, you raised an interesting issue, but it has nothing to do with post-quantum, in my opinion, right, is certificate expiration. That's a problem we actually have today. You know, the device cert says it can live forever. We don't say anything about the rest of the cert chain. And so that's one of the unintended consequences of coming up with a standard, and you think you've specified everything and you haven't. So I'm kind of wondering how to phrase this next question. It's like, you know, all right, let's, all right, go ahead.
So I'm trying to understand what I heard from the panel. Are we saying that SPDM is not going to provide a hybrid sort of option in the negotiation? Is it going to be only traditional versus PQC? Is that what I heard?
So Brett, you want to?
Yeah, so that is the current plan. And part of, yeah, for 1.4, that's a good point. And part of that is just trying to make sure we don't have we don't have any more dependencies than we need, right? Because hybrid schemes are not fully defined yet. So really, yeah, the cleanest path forward is to just make it one key, and you negotiate the key type.
So, and then maybe I'm not understanding SPDM very well. So I use, let's say I decide ECDSA. I do ECDSA for authentication. I do it for signing attestation. I do it for everything. So that's like all the way down to down in the stack. The whole thing is ECDSA or MLDS, DSA, for instance. Is that what you're thinking, or there are different negotiations for different parts?
Yeah, that's the SPDM 1.4 plan. So two endpoints need to negotiate only one algorithm for signing. But I want to add some point here. So actually, I'm not sure if we really need this hybrid in SPDM urgently, because if you really have a use case that you want to do hybrid, you could have set up two SPDM connections between the same two endpoints, one with the traditional, meaning the requester just lists the RSA, ECDSA as the supported algorithms, and responder would choose one of the traditional signing schemes. And then the second connection, the requester would just list the MLDSA, SLHDSA. So in that case, the two endpoints will have two concurrent SPDM connections. They can do get measurements challenge twice. If you don't feel comfortable with only one algorithm, you can just do the same operation on the two concurrent SPDM connections. Even the key exchange, which is for the secure session establishment, you can do two key exchanges. and resulting two shared secrets or common secrets, and just do a KDF of the two common secrets and get your session key. So if the customers or our users of SPDM really wants hybrid, they could do that in SPDM 1.4, just do the two concurrent sessions. So that could be a workaround. Even the device could have two UDSs, or maybe same UDS deriving two different keys, one for MLDSA, one for the ECDSA, and two separate key certificate chains. That could also be a solution. So we don't have to worry about one certificate carrying two public keys and two signatures. And you also worry the signature should be signing each other or just concatenated. There's a lot of things going on. Maybe the independent two certificates will be cleaner in this case. And maybe 5 years from now, people are comfortable with only PQC, then you simply drop the traditional searching and traditional SPDM connection. You don't need any hardware change.
So from what I understand, today, I don't remember which spec, is it SPDM dice binding or which one talks about the slots and you know, requirements about slot 0. So now, let's say I have both. I have to put the traditional in one slot and you know, the PQC in another slot, and I have to make sure which UDS I'm using. I'm using this UDS or the other UDS.
Well, yeah, so the individual slots are actually based on the algorithm you negotiate.
Yeah.
Okay.
So in truth, you know, if you look at the spec, let's say you negotiate RSA, you would then have an RSA set of slots. And then you negotiate to ECDSA 384, you would have an ECDSA 384 set of slots. So there are ways that SPDM can help you manage that.
Okay.
So there's more than one slot zero. It's probably not
And
Yeah,
if I have some kind of hardware dependency on my slots, I have to.
It's algorithm based, right? Because if you follow through the steps of the algorithm, you do the get cert after you can negotiate which algorithm you want to use.
I mean, no matter what when you ask for slot 0, you know, if I negotiate RSA and then I say give me slot 0 and you give me an ECDSA key, that already doesn't work, right? Like it already needs to be algorithm dependent.
Right.
I also want to add on to what Xiaoyu said. Like, I definitely agree that there are schemes that you can do with multiple SPDM handshakes to get all the hybrid properties that we want. There are some like crypto footguns there to do it wrong. So I definitely think it would be great for DMTF to specify, not necessarily in the main SPDM spec, but you know, guidance documents on the best way to do these schemes or suggested ways to do these.
It's a good idea.
Actually, if I could follow up, that was my question. I was just wondering if it made sense to codify somewhere, you know, that usage model. I was following you, Xiaoyu, it makes sense, but some guidance or, I don't know, maybe even consider in the negotiation, you know, some new flag that says I want to, you know, they're separate, but just give me them both, you know, classical and
Yeah, I think especially so like get measurements or anything that's just signed and you're worried about authenticity is relatively straightforward. But anything where you're worried about like store now, decrypt later, anything where the information is secret, the chem handshakes that you have to do are a little more nuanced. So I think we can't just leave that to people to figure out on their own.
So I want to turn that question around. Do you think DMTF is the right people to do that advice, or should it be TCG, or maybe OCP security?
Yeah, I don't think it has to be DMTF. I think OCP is another great forum for that because it's not, I don't necessarily think we're requiring changes to DMTF specs. Although I guess with the suggestion of like maybe you have a flag that, so I think it maybe depends on the solution actually. Like if the solution does depend on new features in SPDM, then I think having DMTF involved is great. But I don't think it has to happen in DMTF.
you know, we're just stuck in this mud waiting for hybrids. I mean, this is a practical way to address that in the near term.
Yeah, absolutely.
It's yet another dependency, right? And you know, if you're trying to get a spec out the door, and we use GitHub for the spec. And it's kind of funny, we're talking about PQC, and meanwhile, there's all these other polls making it into the spec. So there's other features going into 1.4. If somebody came forward with a hybrid and had those dependencies, we could start the pull now and then just wait for the dependencies to go final, make sure our stuff works, and put it in the next version. We run the risk of turning the crank on that version, though, and getting, you know, the industry already isn't caught up to 1.3. So, you know, we know we got to get 1.4 out there, though. So, Jeff, did you have a?
I guess a comment. So I had the same thought that if it's a get measurements at a station, do it twice, and you've got your hybrid properties. With the key exchange, yes, you can KDF those together, but I'm thinking about, okay, how do I do IDEKM with that? I think you need some kind of DMTF spec to say, if you're going to do a hybrid, you got to run these things twice, and then SPDM secure messages look like this with a different key schedule. It seems more like clean to just say, here's a hybrid algorithm identifier. It happens to mean MLChem plus ECDH, and this is how you combine it.
Yeah, I guess I think there's maybe steps to this where, like, in 1.4, it's reasonable to specify just the algorithms and then have schemes on top of that. Because, so like I mentioned that there's a composite signature spec in IETF for hybrid signatures. The situation for ML Chem or for Chem hybrid is there's several competing specs in IETF, and it's not really clear which one is going to be the path forward for the industry. So yes, SPDM could just pick one that looks reasonable and go with it, but that there's a little more of a
Risk.
Yeah, a little more risk there.
Yeah, and stuff like that with, you know, the dependencies on like hybrid chem and having multiple specs fighting it out, right? That's scary as a spec writer to try to look at that, because you know that basically would mean we're just delaying getting post-quantum SPDM out there, and you know that runs counter to the urgency that the industry seems to have.
Yeah, I don't think we should delay singly post-quantum on that. With certificates, there's obviously like you got to get it consumed by OpenSSL, so match IETF. With the chems, maybe there's a bit more freedom to do what makes sense inside SPDM.
That's fair. Yeah.
Well, there's a lot of other questions we could probably ask too, you know, like when are we going to see devices that support SPDM post-quantum, you know, what's the effect on the control plane, what about the certificate signing authorities, everybody, you know, are you going to be able to do this, do you think you can actually do it in just a firmware update if you've got some of the silicon there, you know, there's a lot of other questions. Unfortunately, we're out of time. Feel free to grab any one of us, you know, either after the session, or we've got a couple of ways to give feedback to DMTF. We actually have a public forum that you can go to, and it's just like any other bulletin board kind of thing where you can ask questions. And in our agenda every week, we go through and look and see if there's any new questions, and we answer them first, one of the first topics we do. So if you can't get hold of us, and you know, all our names and emails part of the registration. So feel free to drop us a line or post a question or grab one of us after the session. Thank you, panelists, for coming up here, and thanks everybody for the good questions. Really appreciate it.
Thank you.
Thank you. Thank you.